Hi everyone. I think there's been some problems in the respiratory system in understanding blood gas concepts, and specifically in understanding how gas and partial pressure relate to the concentration of dissolved gases in the plasma. So I want to go over this just a little bit, and I think where we need to start is with Henry's law. So if you look on page 838, you can read about Henry's law and the partial pressure of dissolved gases. So the first concept is that total pressure is just equal to the sum or the addition of each individual pressure. And in particular, what we're talking about is the pressure of oxygen and the pressure of carbon dioxide and the pressure of nitrogen, and we have just a little bit of pressure of water. So I'm trying to write H2O very small right there. And what we know is at sea level the total pressure is 760 millimeters of mercury, and that's equal to the pressure of oxygen, which is 159 millimeters of mercury, plus the pressure of carbon dioxide. That's only 0.3 millimeters of mercury. Very little, right, compared to what's in our blood. The pressure of nitrogen, which is 597 millimeters of mercury, plus the pressure of water, which we're going to estimate at 3.7 millimeters of mercury, or 0.5%. So the second concept I want to get across is that when we increase the pressure of a gas, then we're going to force more of that gas into solution. So when we increase the pressure, more gas dissolves into the solution, correct? So, for example, if we increase the pressure of oxygen from 159 millimeters of mercury to 760, like if you're breathing through a mask in a tank, then we will increase the amount of dissolved gas or dissolved oxygen in a solution. In this case, in our plasma, right? So what we're talking about is dissolving oxygen in the plasma. So this is described pretty well on page, I think it's 839. If we want to know how much gas is in solution, we need a new concept. And for that, we need this thing called solubility. So all gases have the ability to dissolve in water or in liquids. And what we know is if we increase the pressure of the gas above the liquid, we force more into the liquid, and we can increase the concentration. But if we want to understand the total amount of gas in solution, we need to combine this concept of partial pressure, so if we stick with oxygen, PO2, and solubility. So what I want to really reinforce is the total amount of gas in a liquid depends upon the partial pressure and the solubility. This whole concept of putting that gas to breathe pure oxygen is increasing the partial pressure, and by doing that we can increase the concentration of oxygen in our plasma. So we can't really change the amounts very much because we don't have physiological control of solubility. What we know is that the amount of CO2 in our plasma is much greater than the amount of O2, and that's really because the solubility of CO2 is much greater than the solubility of O2. And we just can't control solubility. So now let's talk about the total amount of oxygen in our blood. This is covered pretty well on page 842 in your textbook, and I encourage you to read it. But when we talk about the amount of oxygen in our blood, we need to know how much is dissolved in the plasma, correct? So that's dissolved. And we also need to know how much is attached to hemoglobin, which is